Hi, today we're going to talk about percentiles. A percentile P sub k is a value of the input variable or random variable x, so that k% of the population has that value of pk or less. And in terms of a statement of probability, it would take this form. So the probability x is less than P sub k is equal to k%. So as an example, the life of a component has an exponential distribution with mean equal to 10 years. Our goal is to find the 85th percentile of these components, i.e. how long does 85% of these components last? Okay. So one thing that's important is that for the exponential, the exponential density is given by this. So 1 over 10 times e to the minus x over 10 for x greater than 0. So we start with that definition in red. But we'll notice that k%, hey, that's equal to 0.85. So we want to find the probability x is less than or equal to p sub 0.85. I'll just leave the 0.85 and just leave it as a p. The k%, this will be 0.85. And if we want to calculate this probability, it's going to be the integral from 0 to p, right? Because that's how we calculate probability. The exponential distribution, it specifies x needs to be bigger than 0. We're told the top limit of integration needs to be less than or equal to p. This will be 1/10 times e to the minus x over 10 dx is equal to 0.85. This is an integral that we can easily recognize from calculus 1. Just do a u substitution with u equal to minus x over 10, or we can just remember the antiderivative here will be minus e to the minus x over 10, and we'll evaluate that at 0 on p. If we want to check this is the antiderivative, we can just differentiate it and see that we get exactly the density function back. Okay, so now we need to solve for this. We plug in the evaluation points, that's p, and also 0. Okay, so this will be e to the minus p over 10 is equal to 0.15. Then we just need to solve for p. In solving for p, we'll get minus p over 10 is equal to the ln of 0.15, or p is equal to minus 10 times the ln of 0.15.